Coriolis. So the uneven heating and the Coriolis effect also plays a role in ocean currents. So here you can see that our ocean currents, how it moves through the different oceans. The blue is the cooler, denser water that's at the bottom, and red is the warmer, less dense at the top water. And you can see how they circulate through the ocean. So the uneven heating of our Earth and the Coriolis effect and the different amount of rainfall and availability of water gives us our climates. So here you can see at the equator you tend to have more tropical climates. You can see wetter. The green represents tropical. Usually you get more moisture, higher increased temperature. And like I said, with the 30 degrees latitude here in the dotted line, you get more drier areas because that cool, dry area is then brought back down. You can see here the different circulations of currents within the oceans, those cooler, denser water and warmer, less dense water. You also get upwelling, which brings up nutrients, happens usually in cooler waters. And you can just see all these different interactions on our Earth and how they determine climate. And sometimes we get changes in our climate. And one type of change that happens once every, let me write this down, 2 to 10 years is this effect called El Nino. And what happens, El Nino, is where climate patterns change and can trigger mild to extreme weather changes over at least 2/3 of the globe. And El Nino Southern Oscillation results from a change in direction of the tropical winds. Trade winds blowing west are weakened, and water tends to warm over here, and you get a drier area over here because of El Nino. So this area becomes warmer and wetter. This becomes drier and cooler, and drier and cooler. And the blue areas get unusually high amounts of rainfall. Here we can look at it more in detail. Here we have normal conditions where the trade winds blow this warm water over to Asia, causing more rain in Asia. And because that warmer temperatures over here, it tends to be cooler over here, causing an increase in upwelling. And what upwelling is it brings up nutrients. And as you bring up nutrients, there's more of that limiting factor for your phytoplankton and zooplankton. Therefore, they thrive, and then the rest of the food chain thrives. So you have larger quantities of large fish stocks, therefore increased food supply for this area. But with El Nino, those trade winds weaken, the warmer climate moves backwards, you get increased rain here, less upwelling, so decrease in quantities of fish, so lower quantities of food for these individuals, and this area tends to be much drier. There's a drought in Australia and Asia with El Nino conditions. Here this diagram shows you how upwelling works. Upwelling tends to happen in cooler waters where nutrients from down below upwells or is brought up. Therefore, for phytoplankton do well, therefore zooplankton do well, therefore fish populations do well, therefore fishermen do well. So we have food availability for humans. So you can see how El Nino is a concern for the humans. Not only because of the fish stocks, but also the drought in Australia and Asia, therefore decreasing in crop production in those areas. We get another factor here, part of climate, looking at weather. And weather is a short-term atmospheric condition in an area. It's usually typically considered in hours or days. Much of weather activity is due to the interaction between the leading edges of fronts moving masses of warm and cold air. So here you can see a warm front and a cold front. A cold front, represented here, is an advancing mass of cold air that stays close to the ground. It is often associated with thunderstorms and high winds. Cooler, clear weather is the result. And I know you've seen this. Think about in the winter when we have a heavy rainstorm. What is the weather like after that rainstorm? Yeah, it tends to be cooler and clear. And that's the result from a cold front. Cold front brings in the big storms to begin with, but after they pass, it tends to be a little bit cooler and drier. Now, a warm front is the boundary between warm mass of air and the cooler air it replaces. It often results in cloudy, rainy days. Changes in atmospheric pressure can also affect weather. And we're going to be doing a little demo with this, looking at creating a cloud in a bottle. And when you have a bottle, let me draw my bottle here, and I put some water in it, and I put a little bit of aerosols from a match. I'm just going to release a little bit of particulate matter in there, which is just stuff like dust in it. When I condense that bottle, when I squeeze it, oops, let me go back here, let me get this. When I condense my bottle, I squeeze it in, you will see that it's completely clear. But then when I let it go, you'll see a cloud forming. And what happens here is the greater the pressure here, the less amount of clouds there are. Where low pressure, you tend to have more clouds and rainstorms and thunderstorms. Some extreme types of weather, we have tornadoes or tropical cyclones. They are extremes of weather that cause much damage. Tornadoes form over land, and tropical cyclones form over warm ocean waters. Tornadoes are most prevalent in the United States and Australia. They are funnel-shaped clouds that form when dry, cold air from Canada meets humid air from the Gulf of Mexico. Oklahoma City experienced 58 tornadoes in one day at one time. Most tornadoes occur in the spring. An extreme weather that we're all familiar with are tropical cyclones, or hurricanes, what we call them here in Florida. Tropical cyclones are formed with low-pressure cells of air moving over warm tropical seas. Cyclones forming over the Atlantic are called hurricanes, and those forming over the Pacific are called typhoons. Forces of hurricanes and typhoons can kill and injure people and damage property. Hurricanes can also flush out extra nutrients from land runoff, dead seagrass, and rotting vegetation from coastal bays and marshes. This results in an increased productivity of commercial import species of shellfish and fish, as well as reduce explosive growth of algae. So cyclones and tropical cyclones, hurricanes, and typhoons can be good for ecosystems, even though they can be damaging for the humans. So looking at climate is the long-term atmospheric conditions of a region, typically considered over decades. And climate is determined by two things: average precipitation and average temperature, which are influenced by latitude, altitude, and ocean currents. And those affect Those affect where people live, how people live, and what they grow and eat. So looking at air circulation patterns within climate, there are four major factors that determine this: uneven heating of the Earth's surface, seasonal change, the rotation of the Earth on its axis, and properties of air, water, and land.